Okay, so I'm Ian Goldberg, of course, from the Cryptography, Security, and Privacy, or CRISP research group here in the Cheriton School of Computer Science at the University of Waterloo. And I'll be talking about battling internet censorship and surveillance using privacy-enhancing technologies for the internet. So we've said internet a few times now. What is this internet thing? Click. Awesome. So the internet, right? Many of you are familiar with it. It's 30 some odd years old now, but only in the last 20-ish years has it really become a major force in global communication, collaboration, and commerce, right? And the global part is one of the coolest parts of the internet. The fact that people all over the world can communicate with each other as easily as if they were down the street is a really nice feature of the internet. So here we have a map with places people use the internet, and there are lots of them, obviously. But drawing a map of the internet on a geographic map like this is somewhat misleading. From the inside, a map of the internet looks more like this. Okay? The internet is really just an interconnected network of networks. Internet, that's where the name comes from. And these networks all over the world talk to each other. And as you can see, the colors here loosely represent geographic regions, and they're all mushed together, right? And one of the really important parts of the internet is that a computer in one place on the internet can talk to a computer in the other place on the internet without having to know where physically that other computer is. And the reason this works is that all these computers all over the world speak common what are called protocols. These are just standards that computers all over the world speak in order to communicate with each other and interoperate properly. Okay? So these computers are speaking this internet protocol and a whole bunch of other similar protocols in order to talk to each other. And as I said, when your computer wants to talk to, say, Google's computer, it doesn't have to know where physically Google's computer is. So if your email is stored on Gmail, for example, and you load the Gmail page, you don't know where that email is stored. And in fact, it might be stored in lots of different places for lots of different people, and it might even move around. If you travel to Europe for a while, Google or Microsoft or whoever's hosting your email might decide to move your email from one country to another country so that your email is closer to you. And you don't know any of this. It's completely transparent to you. Okay, and this is one of the really nice features of the internet, that it facilitates this kind of global communication pretty much transparently. Okay? So this feature of you not having to know physically where the computer you're contacting is located is commonly referred to, of course, as the cloud. So in the cloud is where your email is stored. The cloud is where your pictures are stored. The cloud is where your online video chats with your family and friends happen. And it's where, of course, all the stuff that many people say is the #1 reason for the internet existing is stored: funny pictures of cats. Okay? So this is the cloud. All right, so we have a sense of what the internet is, why it's useful for global communication, collaboration, commerce. Let's talk about another important word from the title of this talk: privacy. What is privacy? This is actually an extremely complicated question, much more so than most people realize. So if you ask people, what is privacy? One answer you will often get is, well, privacy is dead. So the question is, the first question I want to ask is privacy dead? And this isn't a new question. People have been asking this question for a long time. Here's a Newsweek magazine cover from 1970, okay, asking, is privacy dead? I will warrant to you that if you have to ask this question for over 45 years, it's probably not. And we'll get back to that more in a bit. So, if privacy is not dead, what is it? Like I said, this is a complex question. Theorizing about privacy is not my particular research area, but there are very well-respected scholars in this area. One of the most respected is Daniel Solov, who's a law professor at George Washington University. And he has books like Understanding Privacy, Nothing to Hide, The False Trade-off Between Privacy and Security, and other works such as a paper called But I've Got Nothing to Hide and Other Misunderstandings of Privacy that students who have taken my seminar course in Privacy Enhancing Technologies will be familiar with, of course. Okay, so in these works, particularly this last one I mentioned, Solov tries to bring together a lot of different aspects of things we consider as privacy, right? And it's important to note that it's not just about secrecy. Privacy and secrecy are not the same thing, okay? Keeping private information secret is one aspect of privacy, but there are lots of other aspects as well, okay? And Solov, in this last work I mentioned, But I've Got Nothing to Hide and Other Misunderstandings of Privacy, gives a very nice example. So here are two classic works from literature, George Orwell's 1984 and Franz Kafka's The Trial. And Solov looks and compares and contrasts the privacy issues in these two books, okay? So in 1984, as you're probably familiar, the privacy issue is one of surveillance. Okay, Big Brother is watching you, and because Big Brother is watching you, people self-censor, right? This is called chilling effect, and because they know they are being watched all the time, they change their behavior, and they don't do what they would want to do, perhaps. All right? So that's in this work. In The Trial, the privacy issue is completely different. So in The Trial, the main character, Joseph K., is put on trial for what he doesn't know. He's not told. No one presents to him any evidence, any reason he's on trial. The privacy issue here has nothing to do with secrecy. The privacy issue here is one of transparency, one of accountability, and one of autonomy. Okay? In more Kafkaesque settings, you have a bureaucracy, for example, that decides that you are a bad person and, for example, doesn't let you board an airplane. Okay? So we've seen this just from a few weeks ago, a story about dozens of children that are on the no-fly list. Why? We don't know. Right? They won't say. How do you get off it? We don't know. They won't say. Can you even do it? Just recently, there was a case in the United States. It concluded last year in, well, I guess 2014, so a year and a bit ago, that was going for 7 years. It's called the Ibrahim case. And Ibrahim was a Malaysian architect who was on the no-fly list. And she sued the US government saying, why am I on the no-fly list? Take me off the no-fly list. And for 7 years, the US government said, no, we can't tell you why you're on the no-fly list because that would compromise the national security of the United States if you were to know how people got on the no-fly list, right? And for 7 years, they fought, and a year and a bit ago, they lost, and they had to tell her why she was on the no-fly list. And the reason she was on the no-fly list, remember, they protected this secret because divulging it would violate the national security of the United States. The reason she was on the no-fly list is because a DHS employee had checked the wrong box on a form. Okay? And the government in that trial had even gone to such lengths. While the trial was going on, Ibrahim wanted to call witnesses. The government put the witnesses on the no-fly list so that they could not come to the trial. Okay? This is almost a definitional example of Kafkaesque, right? But none of these issues have to do with Ibrahim's secrecy, right? The privacy issues here are much broader, right? Privacy isn't just about secrecy. Privacy has to do with freedom, privacy has to do with autonomy, and privacy has to do with dignity, right? Being able to act on your own conscience is what privacy is all about. Okay? So we've talked about the internet, and we've talked about privacy. Now let's talk about privacy on the internet. Okay? Many of you will be familiar from the summer of 2013. There was an explosive kind of sea change in how people viewed privacy on the internet when Edward Snowden leaked a whole bunch of documents, okay, that talked about what various governments were doing clandestinely to surveil the internet. Mostly surveillance, also some amount of censorship there too. And the internet, and not just the internet content, but individual internet users, right? But it's not just the US that does this, of course. The UK, which we know from the Snowden leaks, has programs like Tempora, which just basically keep a copy of all internet traffic entering or exiting the UK in this large 3-day ring buffer that they can then go back and pick out things at will. So a law is going through their parliament right now. It's called the IP bill. Here, IP does not stand for either internet protocol or intellectual property. It stands for investigatory powers. Okay? So the investigatory powers bill is going through the UK right now, and it's pretty bad from a privacy point of view, and various panels are saying it's overreaching, it might be technically legal, but it's bad policy. But of course, there's a majority government right now, so the chance of it not going through is perhaps pretty low. Okay? And lest you think we are immune, of course, Canada has its own dog in the fight here, as it were. So the cyberbullying bill that was brought in recently has this much in it about cyberbullying and this much in it about internet surveillance, right? It's really a lawful access bill, and in fact the fourth or fifth iteration of the lawful access bill put forward by first the Liberal government in the early 2000s and then the Conservative government several times after that, and it was finally passed again when the Canadian Conservatives had their majority in the previous government. Right? So Canada does this too. Okay. So, of course, one of the big issues with privacy on the internet is surveillance and censorship. So, as I said, it's not just countries you think of immediately. Like the US, you know, surveils the internet. China, you know, censors a lot of the internet. But lots of different countries do this too. Okay? And it's not even just countries that do this. Right? Companies also surveil the internet. One of the things we saw from Snowden is this program called PRISM. This is one of the very first leaks from Snowden back in the summer of 2013. And what this program is about is that these 9 mostly major players, like Microsoft, Google, Yahoo, Facebook, and so on, according to this slide and these documents, cooperate, perhaps wittingly, perhaps unwittingly, with NSA and perhaps other government entities in order that the NSA can say, please give me some information about this person, their email, their chats, whatever. And according to this, they have access directly into these companies' systems. Okay? So it's not just governments doing this, companies do this as well. And so we would like to enable people on the internet to protect themselves. Okay? Because the internet is global. Governments are local in that sense, right? And does it really make sense that the US government should be able to read all the communication between 2 Europeans, right? The US government says, yes, of course that makes sense. They're foreigners, and spying on foreigners is what the NSA does, right? And in fact, the NSA needs no legal authority. Well, one of the points, needs no judicial authority. It has all the legal authority it needs to spy on foreigners. It doesn't need to get a warrant. It doesn't need to have particularized suspicion, right? This is why it's called mass surveillance. They just grab everything, right? And they now have this new facility that they're working on in Utah that just has huge amounts of storage, like unbelievably unbelievable amounts of storage. And they're just going to put everything there. And that way, if sometime later in the future they decide, oh, you're of interest now, let's go back in time and see everything you've ever done online. And they can just pull it off the servers in Utah. Right? So this basically gives them a time travel warrant, which, depending on who you ask, probably is not what the framers of the Constitution in the US and the Fourth Amendment had in mind when they said no warrant shall issue except by particularized suspicion, and so on. Okay, so this brings us to the field of research that I work in, privacy-enhancing technologies. And this is a really fun, I'll get back to that later, and really close research community. We have, of course, our own symposium, Privacy Enhancing Technology Symposium, now in its 16th year. And we work on making privacy-enhancing technologies, making them better, seeing what their limits are, breaking privacy-enhancing technologies. That's also important so that you know what the limits are and you can improve them. And our work is cut out for us, right? Because many of you may be familiar with like older privacy-enhancing technologies, like things you can use to encrypt your email, right? And you probably know that they have this completely justified reputation of being extremely complicated to use, right? So I liken it to this kind of cockpit with all the knobs and buttons and switches, except this is actually easier to use because it has nice graphical displays that the older privacy-enhancing technologies don't even have, right? So this was the state of the art decades ago, but we need to do better, right? Because people can't use this in any reasonable way, right? It won't actually protect them, right? And our goal is to not just give people technologies if they want them, right? If they say, oh, I should get one of these privacy-enhancing technologies and protect my communication, sure, they should be able to download it and use it. But even better would be That's just how the internet works, right? Whenever you communicate online, it should be the secure way and the private way. You should not have to decide, do I want to send this privately or do I not want to send it privately? You shouldn't have to think about that. You should just say, oh, I want to send my friend a message, and it should just be secure and private and all these nice things, right? You shouldn't have to worry about that. And in the decades since this was the state of the art, we have come a long way. All right? So first I'll show you one privacy-enhancing technology that all of you use. And the benefit of having these privacy-enhancing technologies that are easy to use, of course, is that otherwise people get really frustrated and they might not want to install them at all, right? So here you may recognize these people. Of course, we have Edward Snowden on the left, and we have Glenn Greenwald, the reporter, on the right, right? And this is from the movie Citizen4, Oscar-winning documentary from last year. Highly encourage you to see it. So Snowden tried to get Greenwald to communicate with him securely and privately, and failed, right? Greenwald did not want to put in the effort to figure out how to use these secure tools that were very complicated to use in order to talk to someone he's never heard of and probably doesn't have anything interesting to say, right? So Greenwald almost lost the biggest story probably will be of his career because of how hard these older systems are to use, okay? As it turned out, then Snowden contacted Laura Poitras, and in order to make a secure channel there, they had to go through Micah Lee of the Electronic Frontier Foundation, and Micah has a very fun read story about how that all went down. That is a fun thing to look at. And anyway, through Laura convinced Glenn Greenwald to get with the program and get everything set up properly. And so it did, okay? Right. So what are we seeing here? We're seeing, of course, is the UWaterloo homepage, but this is a privacy-enhancing technology you use every day. What? What privacy-enhancing technology do you use every day here on the Waterloo homepage? Let me zoom in a little on here. It's HTTPS. Okay, the little lock that shows up in your web browser, that's a privacy-enhancing technology. Okay? And you just use it because that's how the internet works now. When you go to UWaterloo's homepage, it will not let you connect to it in an insecure fashion. You can only connect to it securely. And this is great, right? And until last year, it was a little bit of a pain to set this kind of thing up. If you run a web server, you have to go and buy what's called a certificate from somebody and then set it up, and it was a little complicated to set it up, and every year you had to remember to get a new one or else the old one would expire and pay more money, and it was a mess, and people did it, but not tons of people, right? And here people are people who run web servers. But starting just a few months ago, in December, there was this new project launched called Let's Encrypt. And what this new project is an automated site that generates these certificates for you in a completely free and automated fashion. Right? So now, if you have a web server, it is absolutely trivial to just configure it to say, just get your certificates from there, and then you never have to think about it again. When the certificates expire, they automatically renew, and then anyone who connects to your website is protected. Right? So with this new scheme, we're getting to the point where it's it's almost bad manners to run a web server that doesn't protect their users, right? Because it's so easy to do it now. And as I said, Waterloo has been doing this for a long time. And in fact, Waterloo has configured their web server more securely than many banks, which is really nice. And now everyone on the internet's going to try to attack the web server. Don't attack the web server. OK, so this is an example of a really big success in privacy-enhancing technologies in that people all over the world use it automatically, right? And there's not all these knobs and switches. There are, in fact, a bunch of knobs and switches. If you go into your settings of your browser, you can break things horribly by flipping a bunch of knobs and switches. So don't do that, right? The point is that the default way should be the secure and the private way, right? And in fact, should be the only way, right? It's in kind of our medium to long-term research agendas to make it so that there's no plain text, no unsecure communication on the internet at all, right? That should never happen. And it's not too hard to make it never happen. And we hope we will get there in the foreseeable future. OK, here's another example, right? So here are some applications that allow you to send short messages, text messages, instant messages, chats like that, right? So this is a project I work on called Off-the-Record Messaging, or OTR. And here, instead of the user interface being all these switches and knobs, the only user interface is this little symbol here. It says, you are private, just like the little lock on the web browser, except there are reasons I hate using locks as icons for security notifications, but we don't have to talk about that, right? So it says private, has a little picture of a guy, yes, private. And that's it, right? When you talk to someone, if you have OTR in your chatting software, and they have OTR in their chatting software, and there's OTR available in all kinds of different clients. It's not like you have to get a special OTR chat client, right? It might already be built into the one you use. It'll just start, and you'll be private, and you may not even realize it. And again, that's the goal, right? We want to give people privacy-enhancing technologies almost against their will, right? We just want it to be, that's the way the internet works, right? The private way, the secure way. Okay? So that's OTR over here. Again, there's a project from our research group here in CRISP. This, of course, is not a project from our research group. Anyone recognizes this as iMessage, right? But again, this is a great example. If you use iMessage and you talk to someone else who uses iMessage, your communications are encrypted. They're private. You probably didn't even know that. Okay? And that, again, is the point. You shouldn't have to care. Okay? It's not perfect. None of these systems are perfect. But being able to, by default, protect your messages even against some kind of adversaries but not others, you're not going to be able to protect yourself against the NSA if the NSA is targeting you. If they want your messages, they're going to get your messages, right? Because none of the hardware you use is secure in the first place, right? Forget the crypto. They just get into your phone or your laptop or whatever and just steal stuff from there, right? One of the other things we saw in the last couple of years is the TAO book, the Tailored Access Operations branch of the NSA, with all these little gadgets. It's like on James Bond Q, right? They have all these gadgets. It's literal, right? There's this catalog, and you can view it on the internet now, and you just see, oh my God, look at these gadgets. And these are real things. And these gadgets are used to get into people's computers and their phones and things like that, right? So if you're being targeted, there's very little that we can do to protect you against a really powerful adversary that's trying to get you in particular. But against mass surveillance, protecting everybody, right, against just bulk wiretapping or something like that, we can help, right? And that's what these are meant to do, right? So iMessage is great in that, again, you don't even know that this kind of protection is happening. Okay? Okay, so these technologies we've talked about, the encrypted and protected web browsing and the chatting, two systems we talked about, these systems both protect the contents of your messages. Okay, so someone watching the internet or just slurping it up into Tempora or into the Utah site, what they'll see is you were connected to a particular website, but not what you're doing on that site. Okay? So it hides the contents, but it doesn't protect the so-called metadata. Okay, so metadata is information about who's talking to whom, when, for how long, but not what they say. That's the data. Okay? And the metadata is actually really valuable, right? So the metadata allows people watching the network to figure out a whole lot of stuff about who people are and what they do and who their friends are and things like this, even if they can't see what they say, just by looking at who you talk to, for how long, how often, at 3 a.m. Right? You can learn a lot about a person that way. So we also want to be able to protect the metadata. Okay? So as George said in the introduction, I'm the chairman of the board of directors of the Tor project. You may be familiar with Tor. So Tor is a global system that millions of people use every day to protect the privacy of primarily their web browsing, but other kinds of internet usage as well when they go online. Okay? So how does Tor work? I have a little picture here. So here's Alice. And Alice wants to talk to this web server over here. Now, normally, Alice would her computer would just make an internet connection to the web server. And then the web server would automatically learn a lot of information about Alice. Her internet protocol address, for sure, right? But that also can tell the web server things about Alice's location or perhaps Alice's identity. And on the flip side, someone watching Alice's network connection at her end, like her ISP, which might be run by her government, for example, might see Alice is connecting to a particular site, say Wikipedia, and the government might not like that. Okay? And so Alice would like to be able to communicate with this web server without her ISP learning what she's doing or the web server learning who she is. Okay, and that's what Tor is for. So Tor consists of about 6,000 volunteer-operated what are called onion routers. We operate one here at the University of Waterloo. And these onion routers I've symbolized here by onions, and the number 6,000 I've symbolized here by 5. And what Alice does is she picks 3 of these routers at random, and instead of connecting directly to the web server, she goes through these 3 routers. Okay? And the different colors here represent different layers of encryption. Okay, so all these communications are encrypted, and Alice creates this colored circuit to the last of the 3 routers, and then tells that exit router, it's called, please connect me to this web server. Okay? And then this connection doesn't have any cryptographic protection from Tor. Hopefully Alice is using HTTPS, of course, but that's not something Tor provides. Okay? So now, who knows what? The web server now sees, oh, this connection is coming from a Tor node, from a Tor onion router. And so the web server knows someone using Tor is accessing me. Okay, but not who. And there are millions of people who use Tor every day. And they're very diverse, right? So Tor was originally funded by the US Navy. And one of the reasons they want it is because when you have military people overseas and they want to get their email, if the ISP where they are sees a network connection to the Navy's mail server, well, that kind of gives away that there's a naval officer there, right? And they might not want to reveal that, right? But if only Navy people use Tor, then what would the ISP see? Somebody used Tor, but only Navy people use Tor, so that's a Navy person. So the whole point of Tor is that it's not just Navy, it's not just law enforcement, it is law enforcement, it's not just people who want to protect their privacy, it's not just whistleblowers, it's not just lawyers and other people who have to have private communications, it's all these people, right? All using it together. So when you see a connection from Tor, you don't know which kind of person this is, right? So the diversity is extremely important, right? So this exit node is visible to the web server, and what does the ISP see? Just that Alice is using Tor, but not what she's doing. Okay? Great. Tor is really easy to use. You just go to torproject.org, download the free Tor browser, and it's a web browser. It looks a lot like Firefox because it's based on Firefox. And it just opens up, and that browser, anything you do in there, you're using Tor, it's private. Anything you do in your normal browser, not private. Right? So very simple. Just keep track of which browser is the Tor one and which is not the Tor one, and you're good, right? And this one probably has a little onion in it. That's the Tor one. OK? Great. So I said earlier, this research area is fun. One of the reasons I find it really fun is that unlike a lot of research areas, either in computer science or in other fields, in privacy-enhancing technologies, we have active adversaries, right? When we make something to protect your privacy, someone else in another part of the world, perhaps, is going to make something to break the privacy that you got from our thing. And then we're going to make something that fixes the privacy or gets around their breaking thing, and they're going to get around that, and so on, right? And this is a fun game, right? And it gets us lots of publications, right? So I'll give a couple of examples. So as we pointed out, Alice's ISP can see that she's using Tor. So what happens if Alice's ISP is run by the government, for example, and they just say, nope, no Tor for you, blocks Tor. If that connection looks like Tor, just cut it off, right? Then it doesn't matter if Alice is trying to go to Wikipedia or just get her email or whatever, it's cut off. So one of the things we've done here in our research group at CRISP is something called Skype Morph. So what Skype Morph does is here's what Tor traffic looks like. And Skype Morph takes your Tor traffic and changes it to look like a Skype video call. And so your ISP, if they watch the internet, it looks to them like you're making a Skype video call. Okay? And so they have a choice now, even if they know this exists, right? The important thing in all of these systems is the existence of the privacy-enhancing technology can't be a secret. If your system only works when the existence of the technology is a secret, no good. Why? Because we've published it, and we want lots of people to use it, right? The people we're trying to protect you against have a copy of the software, and the source code, and the paper describing how it works. And yet it still has to be secure. And that's the cool part, that we can do this, right? So even if the ISP or the government knows that this is in use, and they say, well, that looks like a Skype video call, I could block it in order to block Tor, but then I block all Skype video calls. And this is called collateral damage, right? And this is one of the big tools that people doing privacy-enhancing technologies use, right? Is to disguise your traffic as some other really important traffic that would be, the authorities would be loath to block in whatever country. Okay? So that's one example. Here's another example. So here's Alice. This, of course, is what? The internet, right? Alice wants to use the internet to connect to Wikipedia to read about Tiananmen Square. Okay? Alice happens to live in a country, however, that this normal connection to Wikipedia is blocked by a firewall. Okay? What country might that be? I don't know. Make up your own country. Okay? So Alice's connection is blocked by this firewall that doesn't let you connect to Wikipedia. Okay? So some other technology we've worked on in our research group in CRISP is called decoy routing. So Alice, instead of going to Wikipedia, goes to a totally innocuous website with funny pictures of cats. Okay? So there's this lolcats website, and Alice makes a connection to this lolcats website. Now, I've, of course, elided a lot of complexity in how Alice's information goes through the internet and gets to this lolcats website. I'm going to expose one tiny bit of the complexity, which is it doesn't go directly. It goes from Alice to a router, to another router, to another router, to another router, and it makes its way kind of across the internet to there. Now, what we're going to say is that one of these routers is special. One of these routers hates censorship and really wants to support freedom of expression and democracy. Okay? So that router is here. And now, using the kind of technology that we work on in the group, Alice can use a cryptographic trick on this connection here to signal to this router, oh, although it looks like I'm making a connection to the lolcats website, it's really a bluff. I really want to go to Wikipedia. And then this router here, instead of sending Alice's traffic to the lolcats website, sends it to Wikipedia instead. But anyone watching this traffic, including this firewall, to them it looks like Alice is talking to the lolcats website. And so the firewall lets the communication through. OK, so I'm just about out of time, leaving some time for questions. So some takeaways. The internet is a great tool for spreading your ideas, but it's also a great tool for censorship and surveillance. And so using privacy-enhancing technologies, we can empower individuals worldwide to communicate freely online. Thank you very much.
I assume you're willing to take some questions?
I am absolutely willing to take some questions.
The floor is open for questions, and this is the microphone that is going to float around.
You have to have a mic to ask a question.
Thank you for your talk, Ian.
You have to speak up. The mic's not for the room. You have to speak up.
Okay, thank you for your talk. So one question I have is, we've heard about public censorship, like from governments, but what about private censorship, like from takedown requests from, say, copyright or whatever, from actors, private actors who don't want, like a message to be known, so they take down YouTube videos or some other web pages. How would privacy-enhancing technologies be modified to account for that sort of specific actor?
So this, OK. The camera would have heard that question. So the answer is the privacy-enhancing technologies generally don't care who the adversary is, right? Whether the adversary is, like I said before, it could be either a government, it could be a company. The point is to give you the freedom to decide what you want to do online or offline, what to think, who to interact with, and so on.
Hi, Ian. Technical question on Tor.
Okay.
What's the danger of compromised exit nodes and intermediate nodes? I understand that the bad actors are running some of those as well.
Okay, so I don't want to get too technical at this talk, but if I just flip back to the picture here. Right, so here, this connection, remember I said, is not protected in any way by Tor, right? So if Alice happens to choose this exit router here that is malicious, right? They're run by volunteers. Some of the volunteers may be malicious. And in fact, some of them certainly are malicious, right? And Tor tries to detect these malicious players and ban them. Okay, but if a new one comes up and Tor hasn't found it yet, then this malicious player here could not only read all of this traffic here, but actually modify it. And that can be dangerous, right? So if this exit router modifies this data on the way back to Alice, then they might inject some malicious JavaScript, and depending on how Alice has configured the security level of her Tor browser, there's a little knob, that might be a problem for Alice. Middle routers are not as bad because this guy here doesn't know who Alice is and doesn't know what she's doing. So there's not as much exposure to a malicious middle router. But malicious exit routers are of concern, and like I said, Tor actively looks for them and tries to shut them down.
Okay, considering the fact that the NSA is actually or theoretically able to monitor the whole internet, couldn't they just study the traffic, even though they don't know exactly where Alice's messages go through or which nodes she's using, but just by the time this server connected at this moment to this one and this one at this moment to this one, so very likely that this is the message coming from Alice. So how do you protect yourself from that?
That's exactly right. So when Tor was created over 10 years ago now, it was very clear in the original paper that Tor does not protect against what's called an end-to-end correlation attack. So if the same entity is watching Alice's net connection here and watching the exit node here, then exactly what you say, by looking at the timing correlations, they can figure out that, oh, Alice just sent a bunch of data and then nothing, and then a little bit of data, then nothing for a while, and then a bunch of data. And seeing that same pattern come out over here, they can say, aha, these two ends are linked, right? So right now, Tor does not do a good job of protecting against this. It was hoped that there isn't such an adversary. But now, of course, we know there is. So in the last year and a bit, Tor has been actively working on how to protect against this. And the main tool is by putting dummy traffic on this link over here in order to break the correlation between this end and that end. But that's not rolled out yet, but people are working on it.
So for the surveillance center in Utah, how can they possibly store all the traffic on the internet for a very long period of time?
So we don't know exactly what they're going to store there, right? Certainly Tempora doesn't even store all the traffic on the internet for 3 days, because the first thing it does apparently is it gets rid of all the file sharing traffic and decides that's not going to be interesting to us. And it turns out that cuts down traffic a lot. And I think it also gets rid of like YouTube or something. And so by getting rid of a couple of really large bodies of traffic, it gets it down to a place where it can store it. What are they going to store in Utah when it comes up? We obviously will not be told, unless Snowden v2 comes and tells us, right? If you're listening, please do.
Ian, an absolutely fascinating talk and area of research. And I'm coming at this from the point of view of being a novice. So my question really is there a distinction between your terminology of privacy-enhancing technology on the one hand and encryption on the other? And where I'm coming from is this. Encryption to me means you code something in a way that can't be normally read. On the other hand, it looks like what you're doing here is shunting traffic through a rabbit warren of routes, if you will, and confusing the would-be surveillance activity.
Right.
So, and if that distinction is real, and it may not be, but if it is, what is the rate-limiting step in internet security? Is it encryption itself, or is it this security or privacy-enhancing routing that you're doing?
Okay, great question. So there are, in fact, so encryption and privacy-enhancing technologies are not the same thing. Encryption can be used in furtherance of privacy-enhancing technologies. And as I said here in Tor, these colored layers are each a layer of encryption. So encryption is being used here in addition to the, as you call it, rabbit warren routing. We call it onion routing, but I like your term better maybe. So both those things are being used here. So encryption is used to protect the data, the contents of the traffic. And this routing trick is used to protect the metadata, the information about who's talking to whom. And usually you need to do both. Sometimes you don't. Sometimes all you care about protecting is the data, in which case just use encryption. Things like, I'm going to the Waterloo homepage. I don't care if someone knows I'm going to the Waterloo homepage, but maybe when I read my email on the Waterloo site, I don't want people to read my email, right? That would make sense. And so for that case, it's perfectly fine just to go to the Waterloo site without Tor, but with HTTPS. But if you're going to a site where it might matter if somebody knew you went to that site, say you're checking your email again, you're in a foreign country and you don't want people to know who you work for, right? You're connecting back to your corporate email server and you don't want the people in that country to identify that there's an employee of company X staying at this hotel, right? So for that, you would use something like Tor to protect you. So where is the bottleneck? The encryption is pretty much free nowadays. Modern CPUs actually have encryption built into the CPU. It's just an instruction you can say, let's encrypt this with an algorithm called AES, right? And so that can happen very fast because it's just a CPU instruction nowadays, right? But this routing things over the internet, these 3 intermediate hops may be in totally different countries, and your traffic might have to go across the Atlantic 3 times. And it turns out if that were even the source of why Tor slows you down, we would be cheering. But it turns out Tor has all kinds of other very technical parts that slow it down even more than that, right? So when you browse with Tor, it's slower than if you browse not with Tor, and that's the price you're paying for the privacy. But we are working, one of our major research thrusts in my group is, in fact, to take that cost down, right? To make Tor as fast as possible while still giving you the protection.
Great talk. Thanks, Ian. Where does VPN fit in between the two, Tor and HTTP, whatever?
Right. So VPN, where does it fit in? A VPN is kind of, if you squint at it, it's kind of like Tor if there were only one hop, right? So the danger of having just one hop, of course, is that although the end web server can't see who you are, that hop can. So that hop knows who you are and what you're doing, right? And we've seen in the past VPN services selling their services as a privacy tool, and then on the other side of their website, they sell to marketers, oh look, here I have this list of people and what they do online, And these are special people. They like privacy, so pay more for this list. And that's not good, right? So VPNs, from a privacy point of view, are not as good as Tor because there is this central point that knows everything. I think we're out of time.
I see there are some other hands up, but I think we need to wrap this up so that people may have commitments at 1 o'clock. I'm sure Ian would be more than willing if your questions didn't get answered, if you can approach him after we're finished the session. Is that acceptable, Ian?
That's fine, as long as I can eat my lunch.
You can get to eat the cookie. I've been sitting here watching this, and the analogies are very interesting. We have an onion patch. We have, chasing rabbits down a rabbit hole and a rabbit warren. But in some ways, it looks a lot like a giant game of chess where both the board and the figures keep changing and try to be able to move that forward. I actually like the concept of adversaries in my research group. That's something I've been unable to sort of get into my own research area, but I think I can see how that adds a little twinge to stuff. Ian, great talk. Thank you very kindly.